Now we are going to look at the product rule, which is what we use to differentiate something that is the product of two functions. I will then show you the quotient rule, which is really just a special case of the product rule. When we use the product rule, we are trying to differentiate a function of the form y is equal to fx multiplied by gx. And the example I will use is x cubed times sine x. The first step is to identify the two functions that we have here separately, clearly x cubed and sine x in our case. Like when using the chain rule, we rename these functions u and v for convenience, so we just have y is equal to uv, with u and v defined. The next step is to differentiate each of these functions with respect to x separately, leaving us with du dx and dv dx equal to 3x squared and cos x in our case. The product rule says that if y is equal to uv, then dy dx is equal to u times dv dx plus v times du dx. Simple to remember, and we already have the ingredients written out. Take the first function, x cubed, and multiply it by the other function differentiated, cos x. Then add this on to the second function, sine x, multiplied by the first function differentiated. A slightly harder problem is differentiating a function of the form y is equal to f of x over g of x, and we will use cos x over x squared this time. Here we combine the chain and product rules to create a new rule, which we call the quotient rule. You don't need to derive this, but just know that the quotient rule is a result of the fundamental chain and product rules. We again identify f of x and g of x, and this time we make sure to substitute the top function for u and the bottom one for v. We identify these and again find du dx and dv dx. For us, du dx is negative sine x and dv dx is 2x. The quotient rule says that if y is equal to u over v, then dy dx is equal to v times du dx minus u times dv dx all over v squared. A slightly more complicated formula than the product rule, but just as simple to apply, since we again already have all the ingredients written down. We just sub all our terms into the expression, and we get x squared times minus sine x minus cos x times 2x all over x squared squared, which simplifies down to this. The key to all the rules we use to differentiate functions is to identify the form and constituents of what we are trying to differentiate. If the expression is a composite function, we use the chain rule. If the expression is two functions multiplied together, we use the product rule. And if it's one function divided by another, we use the quotient rule. Always identify the form and then make substitutions for each part of it, keeping all your important results clear so they can easily be accessed and put into the relevant formula.